In this video, we are going to discuss the troubleshooting and the fault analysis. So what is a troubleshooting? So if you have one device, means if the device is having some problem, means we have to identify the problem and rectify it. So that is the main idea behind the troubleshooting. So it is a application of logical thinking combined with a thorough knowledge of circuit or system operation to identify and correct a malfunction. So a defective circuit or system is one with known good input but with no output or the incorrect output. So that is the identification of a problem in the given electronic circuit. So by a systematic approach to troubleshooting consists of 3 steps. One is analysis, planning and the measuring. So let us discuss one by one. Here the diagram, the 2 diagram shows DC power supply with a output value. So this figure 1 shows a DC power supply with is represented by a single block with known input value and the correct output voltage. So by seeing this diagram, DC power supply, regulator output, a constant output here. So by seeing this diagram, you can easily tell that my device is working. What about figure 2? By seeing this diagram, known input value, but there is a incorrect output. The output voltage is not constant one. So by identifying this one, you can easily tell that my device is having some problem. So this is the first one, analyzing. Okay, so analyzing the problem by seeing the output, you can easily tell that by my device is not working in a proper value. So the first step in troubleshooting is a defective circuit or system to analyze a problem, which includes identifying the symptom and eliminating as many causes as possible in the case of power supply. So that is the first thing in the analysis, troubleshooting part. Next one, so the first thing you should do in analyzing the problem is to eliminate any obvious causes. That is, in general, you should start by making sure the power cord is plugged into an active outlet. So that is the first one. Next, the fuse is not blown. The second thing is you have to cautious that the fuse is not blown. And if the in the case of battery powered system, make sure the battery is good working condition. So you have to assure that these 3 things are suitable for the working means, then you can go for the next process. However, in the case of power, but there is an output voltage. Beyond the power check, use your common sense to detect some obvious defects such as burned resistor, because we are using some electronic components. So burned resistor, broken wire, so there is a possibility of loose connection, or in the case of open fuse. Since some failures are temperature dependent, here we are using some electronic components, definitely 90% of the system products are in the temperature dependent. So you can sometimes find an overheated component by touching the electronic items. So if the overheating means, then you can go for the compensation. So by giving a cooling devices, or by go for the overheating component, that is compensation techniques. So these are all the initial steps in the troubleshooting and the fault analysis. Next one is planning. So in this phase, you must consider how you will attack the problem. So there are 3 possible ways in the troubleshooting system. One is start at the input, next one start at the output, and use the off-splitting method. So let us go with the one by one. So what is a start at the input? So it is nothing but take the block diagram. Here the block diagram is having transformer, full wave rectifier, capacitor, that is a filter output, and the next one is a voltage regulator. In this block, so your transformer is the input side. So start at the input side. So by using a calibrated meters or very good output devices like a CRO, you can measure the input of the transformer and measure the output of the transformer. Next, by measure the input of the full wave rectifier, measure the output of the full wave rectifier like this by CRO. So by seeing this one, you can easily identify the fault. So start at the input from the transformer secondary and where there is a known input voltage and work toward the output until you get an incorrect measurement. When you find a no voltage or the incorrect voltage, you have narrowed the problem. Once if you identified, you have narrowed the problem to the part of the circuit between the last test point where the voltage was good and the present test point. So in all troubleshooting approaches, you must know what the voltage is supposed to be at each point. That is, from this point what is a voltage, from this point what is a voltage. So to be at each point in order to recognize the incorrect measurement when you see it. So this is a start at the input, that is from input to output, what is your problem. Next one, start at the output. So from the same diagram you can take, so from this TP4, so measure the output value here and what is our value here found. So measure and again go to the next block, what is your input value here, what is your output value. Likewise you can go with the output to the input side and you have to identify the problem. That is, start at the output of a circuit and work toward the input. Check for voltage at each test point until you get a correct measurement. So at this point, you have isolated the problem to a part of the circuit between the last test point and the current test point where the voltage is correct. So third one is off splitting method. So what is the off splitting method means? So use the off splitting method and start in the middle of the circuit. So again take the same circuit diagram. Here I have taken at the middle of the block diagram. So start with the middle, that is output of the full wave rectifier and output of the filter circuit. By seeing this diagram, output of the full wave rectifier is correct one, but output of the filter circuit is somewhat constant one. Here you are getting a incorrect one. So by seeing this, you can easily identify the fault. So that is a first step, off splitting method. If this measurement shows a correct voltage, you know the circuit is working properly from the input to the test point. So from the tracing, so if you go with the 3 input, that is starting from input side, TP1, TP2, terminal point 3. So if you go with the transformer output, definitely it is a correct one. When you go with the full wave rectifier, definitely it is a correct one. But when you go with the capacitor output, that is filtered output, definitely it is a wrong one. So my identification of the problem is easily narrowed one. So this is a off splitting method from the input side. What about from output side? The same method. From voltage regulator output, it is an incorrect one, and this one is an incorrect one. Again this one is our correct one. So by seeing this one, you can easily identify the fault. So troubleshooting is very easy one by adopting this off splitting method. So these are all the idea behind the troubleshooting while go with the power supply. Next, how to design one regulated DC power supply. Okay, so before going to design, we must know some of the disadvantages of unregulated power supply. Why we can go for the regulated power supply? Okay, so first disadvantage of unregulated means it is having a poor regulation. That is, when the load varies, output doesn't appear constant. So the output voltage changes by a great value due to the huge changes in the current drawn from the supply. This is due to the internal resistance. So due to the poor regulation. Next one, AC supply main variation. So the maximum variation of AC supply from the transformer, it take 6% of the rated value. If it exceeds, means definitely there is a problem in the output. So there is a problem in the AC supply main variation. Another one, here we are using a electronic component, so definitely all the things are temperature dependent. So if the temperature varies, definitely more number of current is involved in this, or more heat is produced, so our devices get damaged. So in order to avoid this, we can go for the regulated power supply. So what is a regulated power supply means? From the output of the power supply, we are giving the value to the voltage regulator. So whatever the value, whatever the changes in the power supply, it doesn't affect in the output value. So that is a regulated DC power supply. So the output from a ordinary power supply is fed to the voltage regulating device that provides a final output. So the voltage remains constant irrespective of the variations in the input side. So how to design one regulated DC power supply means, so we have to take one transformer, one rectifier, one filter, and finally we are having a regulator. So all these things considered, and it is connected in this fashion. So transformer, output of the secondary transformer is connected to the rectifier. Once the rectifier output is connected to the filter, filter output is connected to the regulator. So let us discuss in detail. So the diagram shows the complete circuit of a regulated power supply. So a regulated power supply is an electronic circuit that is designed to provide a constant DC voltage of a predetermined value across the load terminals, irrespective of the AC main fluctuations or the load variations. So to design, or we can go for the regulated DC power supply. First one, we must care about the transformer. So the AC voltage typically 230, this one. So AC voltage 230 volt RMS is connected to a transformer, which transforms that AC voltage to the level of desired DC output. So this value is given to the bridge rectifier. So a bridge rectifier then provides a full way rectified voltage that is initially filtered by the CLC filter. So the filter eliminates the unwanted signals, and it gives a constant DC voltage. Sometimes, so the DC voltage usually has some ripple or AC voltage variations. A regulating circuit, so this one, a regulating circuit, DC voltage usually has some ripples. So a regulating circuit use this DC input to provide a DC voltage that not only has a minimum ripple voltage, but also remains a constant even if the input DC voltage varies somewhat or load connected to the output DC voltages. So it gives a constant DC voltage irrespective of the changes in the input value. So that is the idea behind the design of regulated DC power supply.